With all the buzz around AI coding these days, we wanted to take a closer look at something that might just be a ticking time bomb for businesses diving headfirst into it. This idea of a hidden debt that builds up when AI writes code. Yeah. Especially in those autonomous agentic AI systems we're hearing more and more about.
Well, it's a really critical lens to apply right now. We've been digging into some thoughts from Rajith Krishnan, who's the founder and CEO of LowTouch.ai. They're deep in the world of no-code agentic AI, and Krishnan's been sharing some really insightful perspectives on what could be an overlooked challenge as these systems become more widespread.
Exactly. The headline is The Speed and Efficiency AI Promises, right?
Yeah.
But the undercurrent, according to Christian, is this hidden debt, almost like the interest you don't see accruing on a loan until it's, well, a real problem. Our goal today is to really understand what this debt is all about and how companies can avoid getting buried under it, particularly when it comes to agentic AI.
Right. And just to set the stage, when we talk about agentic AI, we're not just talking about tools that follow simple commands. These are systems designed to operate independently, identifying tasks, making decisions, and acting on them.
Well,
Krishnan, drawing on his experience at lowtouch.ai, sees them being used for things like fully automating customer support interactions, autonomously managing IT infrastructure, and really streamlining a whole range of complex business workflows.
so like digital employees almost.
Kind of, yeah. Think of them as digital employees that can not only follow instructions, but also identify tasks, plan their execution, and learn over time like a self-managing virtual assistant for complex business processes.
Okay, so this hidden debt's a great analogy to financial debt where, the longer you ignore it, the bigger the bill. How does this debt actually take shape in AI-generated code? What are the mechanisms at play?
What's fascinating here is that Krishnan pinpoints a few key ways this interest accumulates. He talks about what he calls architectural decay, the slow erosion of a system's structure over time. Then there are knowledge gaps, where the teams using the code don't really fully understand how it works. And finally, a gradual decline in the overall quality of the code itself. It's not one big failure usually, but a collection of smaller issues that compound.
And the real worry, as I see it, is that those initial quick wins we get from AI coding could actually mask some pretty significant long-term costs,
Yeah.
especially with these agentic systems where a small crack in the foundation could have really wide-ranging consequences later on.
Precisely.
Right.
Because these autonomous systems are designed to act independently, any underlying weaknesses in their code or, how they're architected can be amplified as they make more decisions and take more actions.
Right.
It's like giving a self-driving car a slightly flawed map. The further it goes, the more likely it is to get seriously lost or worse.
Okay, that makes sense. So let's dig into these key drivers. The first one you mentioned was architectural decay, often linked to this acceleration of code duplication. Christian throws out a pretty startling statistic about this, right?
He does. Krishnan highlights that AI-generated code shows something like an 8x increase in duplicated code blocks compared to code written by human developers.
So that's a massive red flag for anyone who understands software engineering principles.
Absolutely. It goes against this core idea in coding called DRY, don't repeat yourself, which is all about keeping code efficient and crucially easy to manage. So why is AI seemingly so prone to this repetition?
Well, if we connect this to how these AI tools are trained, they learn from massive data sets of existing code. And while this lets them generate solutions rapidly, they don't always grasp the higher level architecture of a system
Yeah.
or recognize opportunities to reuse existing well-designed components. Not in the same way a human developer would anyway.
Okay.
It's like asking a brilliant, well, maybe a brilliant but forgetful intern to solve a problem without telling them what everyone else in the company is already doing. This leads to what Christian aptly terms context-blind implementations. Context-blind. Yeah, that really nails it. The AI solves the immediate problem right in front of it. But it doesn't necessarily know or care, really, if that exact same solution or something very similar already exists elsewhere, or if it fits cleanly into the overall design.
Exactly.
The end result, as Christian points out, is this fragmented code base, less adaptable to future changes, and ultimately much harder to maintain this architectural decay.
Right. And it's not just about more work. It subtly shifts the focus of your senior engineers from, innovation to janitorial duties, essentially, which can really stifle long-term growth.
Yeah, that's a great point.
And Krishnan gives a really illustrative example with an AI agent designed for customer support. Imagine if the code for handling a specific type of customer query is duplicated across multiple modules within that agent instead of being in one central reusable place. When you need to update how that type of query is handled, maybe a new policy changes things. You'd have to go and modify that same logic in multiple different parts of the code. That increases the risk of errors and makes the whole system much harder to scale to handle new types of questions later.
Makes perfect sense. Okay, so the second driver is comprehension debt and these knowledge gaps. What does that look like in practice?
So comprehension debt is essentially the gap between the cream that gets deployed and the development team's understanding of how it actually works. Krishnan notes that AI can sometimes generate code that, while technically functional, is really opaque, hard for humans to follow.
Like overly complex.
Yeah, exactly. Think of it as the AI finding a very roundabout and complex way to do something that a human developer might write in a much more straightforward and understandable manner, like a verbose loop instead of an elegant method.
So even if the AI-generated code does the job, the team that has to maintain it down the line might struggle to figure out why it works that way or how to troubleshoot it if something goes wrong.
Precisely.
And this problem must be amplified when a team inherits AI-generated code that they weren't even involved in creating, right?
Oh, absolutely. Debugging and making updates becomes significantly more challenging when the underlying logic feels like a black box.
Mm-hmm.
And Christian brings up a really interesting point about no-code platforms, like his own lowtouch.ai. Even in these visually driven environments, if AI is generating components behind the scenes that lack transparency, he gives the example of an IT operations agent with black box decision-making, it can really erode trust in the system.
Ah, right. Trust.
Yeah, because if the team doesn't understand why the agent made a particular decision, they're much more likely to overwrite it or just revert to manual processes, which ultimately defeats the whole purpose of the automation.
That's a crucial insight about trust. Even in user-friendly interfaces, if the AI's reasoning isn't clear, people will be hesitant to rely on it fully. Okay, the third driver Krishnan highlights is hidden security and quality risks. This sounds particularly concerning, especially in the context of these autonomous agents that might be interacting with sensitive data or critical infrastructure.
It is a significant concern, yeah. Christian points to some worrying trends, mentioning that 70% of AI-assisted developers report increased vulnerability exposure.
Wow, 70%.
Yeah, and this can happen for a few reasons. The AI's training data might include outdated or even insecure coding practices, or the AI might simply fail to properly validate user inputs, potentially leaving systems vulnerable to common attacks like SQL injection.
Right, the classic.
Exactly. These are essentially automated tools that scan code for potential issues without actually running it, and they're finding more security flaws in AI-generated code.
And it's not just about specific vulnerabilities, it's also impacting the overall reliability of the code, isn't it? Christian mentioned something about DORA metrics.
Yes, a 7.2% drop in deployment stability linked to quality issues in AI-generated code based on DORA metrics. And for listeners who aren't familiar, these are key metrics for measuring software development performance and stability. So a drop like that is significant.
Definitely.
And when you consider these quality issues in the context of autonomous agentic AI systems, the potential fallout is much greater. If an agent handling sensitive customer data has a security flaw, or if an agent managing critical infrastructure has quality problems that lead to instability, well, the consequences could be severe. We're talking major data breaches or significant operational outages.
Yeah, the stakes are much higher.
Absolutely. Krishnan rightly emphasizes that while his platform, lowtouch.ai, prioritizes security by operating within an organization's existing infrastructure, maintaining vigilance over the quality of the AI-generated components within those systems remains absolutely critical.
Absolutely. You can build the most secure vault in the world, but if the code running inside has weaknesses, it's still vulnerable. Okay, the final driver Krishnan discusses is what he calls the productivity illusion. This was particularly interesting because we hear so much about how AI is supercharging developer productivity.
It's definitely tempting, isn't it? To focus solely on that headline figure, the 55% faster coding statistic that Krishnan mentions, on the surface, that sounds like a game changer.
For sure.
However, as he astutely points out, this can be a real productivity illusion because it doesn't take into account the ripple effects and hidden costs that often follow that initial burst of speed.
Right. It's not just about how quickly the AI spits out the initial code. It's about what happens next. Krishnan highlights that teams are experiencing doubled code churn.
Double.
Yeah, meaning they're having to go back and significantly rework the AI-generated code much more frequently. Plus, code review cycles are taking 30% longer because human developers have to meticulously examine code they didn't write and might not fully understand.
And that takes serious time and focus.
And then there are the refactoring costs, essentially, having to rewrite significant chunks of code to address the duplication and architectural issues we talked about earlier.
It sounds like teams might initially celebrate the speed, only to feel demoralized later by the constant need to fix and rewrite, a real hit to team morale, potentially.
Yeah, I can see that.
Exactly. So while that initial speed boost might look attractive, all this extra effort in reviewing, rewriting, and fixing bugs can actually negate those initial time savings and potentially even lead to higher costs in the long run.
Right.
Krishnan connects this directly to agentic AI deployments, where a rapid initial rollout might be followed by a significant increase in costs due to dealing with unexpected bugs, lengthy and complex reviews, and resource-intensive refactoring. It's the hidden debt manifesting as real-world expenses and wasted time.
So when we put all these drivers together, the code duplication leading to architectural decay, the comprehension gaps, the security risks, and this productivity illusion, what are the real stakes for enterprises that are increasingly adopting these agentic AI systems?
Well, Krishnan is very clear that agentic AI holds tremendous potential for the future of automation. It really has the power to fundamentally change how businesses interact with their customers, manage their internal operations, and ensure the reliability of their critical infrastructure.
Huge potential.
Huge. However, this hidden debt directly undermines the very things that make agentic AI so valuable: its reliability, its ability to scale effectively, and its security posture. If these systems are built on a shaky foundation of duplicated, poorly understood, or vulnerable code, they simply won't be able to deliver on their promise. And worse, they could even introduce significant risks and liabilities.
Yeah, undermining the whole point.
Exactly. And as you mentioned earlier, this isn't just about more work. It subtly shifts the focus of your senior engineers from innovation to just keeping things running. Janitorial duties, like you said, that stifles long-term growth.
And Krishnan touches on this understandable desire he sees in enterprises for simplicity and speed when it comes to adopting AI. Platforms like lowtouch.ai are designed to cater to that need. But it sounds like we need to be really careful not to prioritize those short-term gains at the expense of long-term sustainability and maintainability.
That's the crucial balancing act, isn't it? While the allure of rapid AI adoption, particularly with user-friendly no-code solutions, is strong, we just can't afford to overlook the underlying quality, security, and maintainability of the code that powers these increasingly autonomous systems. Otherwise, we risk building a future of automation on a foundation that could crumble under its own weight.
Okay, so we understand the potential pitfalls. This hidden debt is a significant concern. But what can organizations actually do to mitigate these risks? Krishnan outlines some key strategies, and it sounds like a fundamental shift in mindset is needed, viewing AI as more of a draft generator than an end-to-end solution.
That's a very insightful way to frame it, yes. Krishnan proposes 4 actionable mitigation strategies, and what's particularly valuable is that he provides concrete examples of how to implement them and the potential impact they can have. The first is AI-augmented reviews.
Okay, so instead of solely relying on human developers to spot these issues, we leverage other AI-powered tools to assist, specifically looking for things like that duplicated code we discussed earlier.
Exactly. Krishnan suggests using static analysis tools for this, and he estimates this could lead to a 40% plus reduction in redundant code.
Wow, 40% plus. That's tangible.
That's a tangible improvement right there. He also mentions that lowtouch.ai integrates quality checks into its platform, which aligns perfectly with this strategy, using AI to check AI's work, essentially.
Makes sense. Okay, strategy 2.
The second strategy is establishing architecture guardrails. This is about proactively guiding the AI as it generates code to ensure it adheres to the existing architectural patterns and API contracts within the organization.
So setting rules for the AI.
Kind of, yeah. Krishnan suggests using carefully crafted prompts for the large language models that power these AI tools to enforce these contracts. This can help prevent the generation of those context-blind solutions we talked about, the potential impact, significantly reducing architectural fragmentation.
Right.
He also points to lowtouch.ai's modular design as a way to naturally encourage this kind of consistent and well-integrated code generation.
That makes perfect sense. It's like setting clear boundaries and guidelines for the AI to operate within. Okay, the third strategy is continuous retraining. Now, this isn't about fundamentally retraining the core AI model itself, is it?
No, not exactly. It's more about deploying machine learning-powered quality assurance pipelines to constantly validate the AI's outputs against established security and quality benchmarks. Think of it as ongoing automated testing specifically for AI-generated code.
Okay.
Krishnan suggests this could catch a significant 63% of security flaws early, which is a huge win in terms of risk reduction.
63%, that's huge.
It is. He also highlights that LowTouch.AI's AI has the ability to adapt and learn in real time from the data it processes, which contributes to this ongoing quality assurance.
That proactive and continuous validation seems absolutely key in maintaining the integrity of these autonomous systems. Okay. And the final strategy.
The final strategy Krishnan proposes is comprehension checks. This directly addresses that knowledge gap we discussed earlier. The idea is to require developers to create clear, explain-back documentation for any AI-generated code they intend to use.
So making sure someone actually understands it.
Exactly. This forces them to actually understand the code's functionality and logic before it gets integrated. Krishnan estimates this could lead to a 58% reduction in knowledge debt, which is a substantial step towards making these systems more understandable and maintainable in the long run.
Right.
He also emphasizes LowTouch.AI's intuitive user interface as a way to minimize the black box nature of some AI-generated components, making it easier for users to grasp what's happening under the hood.
So it really sounds like it's not about hitting the brakes on using AI for code generation, but about being much more deliberate and, frankly, rigorous in how we integrate it into our development processes.
Absolutely.
It's about implementing layers of oversight, establishing clear architectural boundaries, continuously monitoring the output, and ensuring that human teams still understand and ultimately own the code.
Precisely. Krishnan's vision for the future, and it's a compelling one, is that agentic AI has the potential to be transformative. But realizing that potential hinges on this disciplined and thoughtful approach to managing the inherent hidden debt. He emphasizes LowTouch.AI's commitment to this by striving to balance speed and simplicity with long-term sustainability through their no-code platform, their focus on operating within a customer's own infrastructure for enhanced security, their advanced large language model capabilities, and that user-friendly design that promotes understanding.
It really boils down to responsible innovation, doesn't it?
Yeah.
Not just letting AI run wild and generate code unchecked.
Exactly.
The strategies Krishnan outlines, those augmented reviews, the architectural guardrails, continuous quality checks, and that all-important human understanding seem absolutely crucial for transforming these potential liabilities into manageable risks.
Yeah.
And, unlocking the true long-term value of agentic AI.
Absolutely. The core message that Krishnan delivers, and it's a vital one for anyone navigating this rapidly evolving landscape, is that while agentic AI offers incredible promise, it also introduces a significant and often underestimated challenge in the form of this hidden debt that can accumulate from AI-generated code.
And it's so important for you, the listener, especially if you're involved in leveraging AI within your organization, to really grasp these underlying drivers of that debt, the insidious code duplication, those worrying comprehension gaps, the potential security vulnerabilities, and the often misleading productivity gains. Ignoring these factors could have serious and costly long-term consequences for your systems and your teams.
Definitely. And those proactive mitigation strategies that Krishnan shared, the AI-powered code reviews, the establishment of architectural guardrails, the implementation of continuous retraining pipelines, and those essential comprehension checks, they provide a really practical and actionable roadmap. It shows how organizations can proactively manage these inherent risks and ensure they are building sustainable and reliable AI-powered systems for the future.
So, as you're considering how your own organization is embracing the power of AI-driven automation, it's definitely worth reflecting on Regis Krishnan's insights. How are you currently navigating those critical trade-offs between achieving rapid deployment and ensuring long-term sustainability? What concrete strategies do you have in place, or maybe should you have in place, to identify and manage this potential technical debt before it becomes a significant burden?
Yeah, it's a tough question. It really forces us to confront a fundamental question about the long-term health and maintainability of the intelligent systems we are building today. Overlooking this hidden debt now could very well mean paying a much steeper and more painful price in the not-so-distant future.
Definitely food for thought. If you're keen to delve deeper into this important topic and explore how platforms like LowTouch.ai are specifically addressing these challenges, we encourage you to visit their website. It's lowtouch.ai. That's LO-TOUCH.ai. It's a fascinating and rapidly evolving area, And gaining a solid understanding of these potential pitfalls is absolutely essential for truly harnessing the transformative power of the AI revolution in a responsible and sustainable way.